My name is Surya, and we are going to discuss about the naive Bayes in the machine learning concept. So, what is naive Bayes? Actually, the naive Bayes is a concept which is used to predict the new data from the previous past data with the probabilities and forecast a new evidence. So, naive Bayes is basically have three main concepts: past data, evidence, and the probability. It helps a lot in spam detection and disease prediction, sentiment analysis, weather predictions, and document analysis, and also classifications. In simple, we can say that the naive Bayes is used with the old data with the probabilities guess and predict the new data in the future within a smart way. Well, have you ever thought why we call it naive Bayes? What is the meaning of the naive? So with the nav, we can say that it is the features in it are the independent. We can say all the features are independent. With an example, so cloud, sky, and humidity are related, but nav base treats them as separate. Still works very well. That's the beauty of it. Well, before going into the concept, let's discuss about the brief history about the nav base. Based on the Bayes theorem created by the Thomas Bayes from the 1701 to the 1761 period, and later on the computer scientists have been recreating this theorem like and making it build faster and powerful classifications, which works in the symptom disease and also the spam detection systems. Well, let's pop into the noteboard screen then. Let's discuss in depth and with an examples. Well, hey guys, so this is the notepad theme. So let's view here. So this one is the past data. So this is some of the data which you have previously. And here the probability section is going to take place. And after that, there will be the evidences which the forecast data will be here. So with this diagram, we can understand that the naive Bayes is how it's been taking place in the real time scenarios. So, well, naive Bayes uses the old data to guess and the future in a smart way. Well, well, let's see the formula. P of A given B is equal to P of B given A into P of A by P of B. So, what does this A and B and P of A? So A is the thing you want to predict. I mean, which we want to predict. So B will be the evidence you see. And the P of A is the probability of the past data. So, well, let's consider a scenario. Like in the rain scenario. So P of B given A is that if it rains, how often does the mornings cloudy? And what will be the P of B then? How often mornings are cloudy overall? And P of A will be the probability of rain in general. Well, let's see it with a detailed example. So let's consider the rain scenario only. So we have let's take a small question. Okay, then. So we have collected a raining data for the 10 days. So the raining days will be the 4 and the sunny days are 6. So in these days, the cloudy mornings will be uh, so on the rainy days there were 3 mornings cloudy, and on sunny days there were 2 mornings are cloudy. So today morning will it be cloudy, or what is the chance of the rain that today will be rainfall? Well, let's use the base case scenario. So the step one which we'll be following is that the P of A. Let's consider the first one will be the P of A, that will be the probability of the rain. So the 4 by 10, here you can see a value 4 by 10. Why the 4 by 10 we choose? So the number of the raining days are 4 and the total days will be the 10. So it will receive a value 0.34. So let's proceed to the step 2. What is the probability of the cloudy morning if it is raining? So we consider that a scenario P of B given A. So the cloudy given to the rain will be will be. So here we consider the 3 by 4. So why we taken this value is that there are 3 mornings on cloudy in the rainy days and the total days raining days are the 4. So we get a value 0.75. Well, and P of B. What is the P of B? It is the probability of the cloudy morning overall. We need to consider the overall percentage, right? So the cloudy total were the 3 plus 2 because there are 3 rainy days and the 2 sunny days. So total 5 days. So the probability of cloudy will be the 5 and the whole days, like the whole days given in the question. So that will be 10. So the answer will be 0.5. Well, the last step, we check with the Bayes theorem scenario. So the P of rain given by the cloudy, we say that the P of cloudy given rain into P of rainy by P of cloudy. So we just place the values which we received before. See, we received three values with these scenarios, like the probability of the rain and the probability of the cloudy morning if it is rainy. That will be 0.75 and the zero point 0.5, which is for the probability of the cloudy. So we substitute these values in the Bayes theorem scenario and we get a value 0.6. So finally, we can say that the probability of the rain given by the cloudy is 0.6. So therefore, we could say that there is a 60% of the chance that the rain will be happen today. Well, we have seen what is Bayes theorem and why we call it as the naive Bayes and its example with the scenario. Now, my friend JC will continue about the simplest form and I will be again taking over and saying you about the Laplace smoothing method which is main and important in the naive Bayes concepts. And also JC will explain about the simplest form which we use generally and also plays a major role in the naive Bayes.
Now I'm going to explain an example on naive Bayes classifier algorithm. Before finding the example, we'll see the Bayes theorem formula. It is very important for the question. The formula for Bayes theorem is written here. The P of A by B equal to P of B by A into P of A by P of B. It is also can be readable as probability of A given B. So this is the question from the given dataset. Apply naive Bayes algorithm and predict if a fruit has following properties, then the type of fruit it is. So they have given the properties of the fruit and we need to find the which fruit it is, like mango, orange or banana. So this is the given data set. Sometimes they will give data set directly or sometimes indirectly. We need to frame a table for this. For example, they will give data set like we have got 35 yellow mangoes and the sweet mangoes of is 45 and the long mangoes is 0 and the total number of mangoes given is 65. Like this they will ask in the question. We need to frame accordingly to the question. So for finding the which fruit it is, we need to find the probability of mango, probability of orange and probability of banana. For finding the probability which fruit it is, we need to find for the probability of mango, probability of banana and probability of orange. So we need to find three probabilities to get which fruit it is. So for finding probability of mango, we need to find these three attributes of mango probability. For example, let's see probability of mango equal to probability of yellow given mango into probability of sweet given mango and the probability of long given mango. We need to find these three properties of mango to find the probability of mango, these three attributes of mango. So for finding the probability of mango, we need to find the yellow probability and sweet probability and long probability of mango. So for this we use Bayes theorem for each individual properties. So after elaborating we get like this: the probability of yellow by mango is probability of mango by yellow into probability of yellow by probability of mango. The probability of sweet by mango is probability of mango by sweet into probability of sweet by probability of mango into probability of long by mango is defined as probability of mango by long into probability of long by probability of mango. After elaborating we need to find the values to calculate. So for the first one we'll see that probability of mango given yellow. So we can see that in yellow the mango is 35 and the total is 80, and we will write directly by 35 by 80 into, for we need to find probability of yellow next. The total number of yellow mangoes, yellow is 80. So for the total number of items is 120, we'll write directly 80 by 120, and next we will find the probability of mango. The probability of mango, total mango is 65 and the total number of items is 120, we will write directly 65 by 120. Like this we need to find both next two. So the for the next one, the probability of mango by sweet is here sweet is 45 and the total number is 85, so it is 45 by 85. And the next one is probability of sweet. The total number of sweet is 85, the total number is 120, so we can see that 85 by 120. And the next one is probability of mango 65 by 120. And the next one is probability of mango given long. The probability of mango given long is, we need to find the mangoes in the long. So mango in the long is 0 and the total number of mangoes is 40, total number of long is 40, so we will see that 0 by 40. The probability of long, for the long will see that total number of long is 40 and the total number is 120, we'll write directly 40 by 120. And the probability of mango, you can see that 65 by 120. After calculating all these we get the value as probability of mango equals 0. Like this we will calculate for the next two, orange and banana. You can see I have calculated for the orange. So this is the same method used in the previous one, but for the time saving I have calculated for the orange one and we get the value as 0.65. And for the banana part I have got the value as 0.07. We'll write all three values. So probability of mango is 0, the probability of orange is 65, the probability of banana is 0.07. We need to find which one is highest value. So we can see that probability of orange is higher. So so orange is the answer, highest one is orange, so the fruit belongs to the orange. This is how you can calculate the question. So for the given properties, the fruit is orange. Thank you.
Hey guys, so welcome back. So now let's study about the Laplace smoothing method in the nav base. Well, let's get going. So in Navier, we calculate the probability of a class using the frequencies of the words, but sometimes a word may appear 0 times in a class, and when that happens, the Navier gives a probability of 0, which completely breaks the whole calculation. So, Laplace smoothing fixes this problem by adding 1 to every word count that ensures no probability ever becomes 0 and our model stays stable and accurate. Well, here you can see that it just adds 1 to the every count of the word. So here we can derive from the formula that the P of the probability of the word given class is equal to the count of word and class plus 1 by the total words in class plus vocabulary size. So we can observe that here the 1 is being added and in the vocabulary size is equal to the total number of the unique words. Well, let's see with a basic example how this Laplace smoothing method affects and impacts in the scenario. So let's get going with an example. So we just consider a small example like spam or not spam. It is a real life example we can say that we observe in an email pattern. So you see, if there is a one word offer, so in the training data, how many times did the offer appear? Like if the spam has total 10 words and offer count 2, and not spam has 12 words and 0, when we can see that offer never appears in the not spam. So without smoothing, it shows that the value is 0. So this will entirely break the naive Bayes prediction. So let's apply Laplace smoothing and check whether it solves the problem or not. Okay, so let's apply Laplace smoothing. Assume that the vocabulary size is equal to 5. So the words offer, free, win, hello, and meeting. So for spam, the probability of offer given to spam is equal to 2 plus 1 by 10 plus 15, and that is equal to 3 by 15. Then the value we get is the 0.2. So, as coming to the not spam scenario, even though the count is 0, the smoothing fixes it by the probability of the offer given to the not spam is equal to 0 plus 1. So, in the above case and here, we can observe that. So, we can observe that in the above case and here, the one is being added. See, the one is being added. So it changes the whole scenario in the sequence. So we observe that if the one is added and the probability is being calculated, and therefore we receive a value. So by therefore, let's compare our prediction logic. Like in the spam, likelihood offer is 0.20, and in the not spam, the likelihood offer is 0.058. So we can observe that the offer is more likely to appear in spam not than not spam. Because the probability is higher for the spam, the email is likely to be a spam. So, with our understanding, we could probably derive that the Laplace smoothing avoids zero probabilities by adding 1 to all word counts, making naive Bayes a stable and accurate method. Alright guys, so that's the complete breakdown of the naive Bayes. So from the understanding, we found that the Laplace smoothing is needed and finally for the simplest form, how the model actually works. So we saw that the naive Bayes uses the probability and how zero counts can break the model and how Laplace smoothing fixes the problem in a very simple but just adding by one. So and with the simplest form of the calculation, we can see exactly where it is happening behind the scenes. If the video helps understand the nerves more clearly, make sure to hit the like button and please subscribe our channel. Thank you.